Hello, my favorite student. Welcome to another video on linear algebra. So today we're going to be going over some more vectors, and more specifically we'll talk about the norm, the dot product, and the distance in Rn. So what is norm? I know that's kind of weird, but it's actually a common mathematical synonym for length. So essentially the norm of V is the length of V or the magnitude of V. Okay? So let's get right into it. Again, if you hear some snoring in the background, it is actually my dog. He's having a wonderful nap, and I am very envious of him. Okay. So, oh yeah, we were talking about the norm. Norm. The way the norm looks, we have this y-axis and this x-axis. Then we have this point, V1 and V2. And it is a vector like this. Okay. And that's V2, V1. Alright, and this is actually the norm. So the norm could be let's just say this is the norm, magnitude, or the length, because you'll see it and hear it two different ways. So the magnitude is written like this, or you might see it like this. It is the same thing. The only difference is this vector is being insulated by one jacket, and this vector is being insulated by two jackets. I don't know. It's the same. So the way that you're going to find it, the way that you're going to find the magnitude is by taking the square root of the first component squared plus the square root of, the square of the second component. And that's only for 2D. So if it was in 3D, you'll find the magnitude like this. V1 squared plus V2 squared plus V3 squared. All under the square root. So that's a 3D, 2D. Does that make sense? My favorite student. Okay, good. Let's move on. Okay, let's start off with R4. Ooh, that red is eye-piercing. Okay, R4. We have a vector that's equal to -2, 3, 3, -1. And we want to know what the magnitude of that vector is. Well, it's just the square root of all the components squared, -2 squared plus 3 squared plus 3 squared plus -1 squared. And that's going to equal the square root of 23. Okay, so we found the magnitude, or we found the length, or we found the norm, whichever term you want to use. But now there's something else that you might want to learn, and it's called the unit vector. So the unit vector looks like this. And the unit vector is equal to 1 over the magnitude of your vector times the vector. Okay, so let's find the unit vector of this vector v. And just to know, the unit vector has a magnitude of 1. Okay? So, let's find that unit vector. So that would be essentially... Oh, my pen's not working. Oh, my pen is dead. Perfect. Give me one sec. So if we were to find the unit vector now, that would be 1 over the square root of 23 times this vector, negative 2, 3, 3, negative 1. And if you were to distribute that, you just put it negative 2 above the square root of 23, 3 over the square root, 3 over the square root, negative 1 over the square root. Okay, so that's the unit vector. I know one of the problems in the book asks for an opposite unit vector. Well, you would just find the unit vector like this. And we just add this minus. And that actually just gets you like the opposite. In the opposite direction. Okay, so if that was the case, you would have this would be a positive, that would be a negative, that would be a negative, and this would be a positive. And that's all that would change. Okay, so moving on. The last thing I want to talk about is the dot product. So if we're dealing with a problem regarding the dot product, maybe I should tell you that this is sometimes called the Euclidean inner product. I just want to make sure that you are prepared for anything. Okay, so you can see the dot product in two ways. One is this way. U dot V is equal to the magnitude of U times the magnitude of V times cosine theta. So that's if you're given an angle or you're looking for an angle. That's what you use. You could also see it in terms of this. U times V is equal to U1. You're multiplying each of the components and then adding them all together. Plus U2, V2, plus U3, V3. So very quick, if we add the U vector is equal to 1, 1, 1, and the V vector is equal to 2, 2, 2, and we found the dot product, that would be 1 times 1, 2, 1 times 2, plus 1 times, I'm going to change it, just so that there's a little bit of distinction. Huh. The writing is terrible. Okay. Plus 1 times 6. equals 2 plus 4 plus 6. And it does give you a scalar. So there it is, folks. That is how you find the dot product. Let's see. Yeah, I think that's it. So I hope this was helpful in some way, and I hope that you learned something. Hopefully I explained something well enough for you. If this did help you out, please let me know by leaving a like on the video or commenting in the comment section. If you so want to, you can go ahead and subscribe and hit that notification icon so that you're notified whenever I post, so that you can always have all the new linear algebra material ready for you whenever you need it. So, all right. I hope that made sense to you, and I hope you're doing well in school.